Assalamualaikum warahmatullahi wabarakatuh. To panel 1, Dr. Syukur, panel 2, Dr. Amran, and Ms. Wilda as panel 3. Today, I will going to present my final year project 1. And the title is Comparison of Different Cooling Methods for Milling of Titanium Alloy. And this project is wholly supervised by Professor Madya, Dr. Liu Peijun. Next, we will go to the introduction. Firstly, what is milling? Milling is a widely used and known as metal removal process in the manufacturing industry. This milling process is involving generation of high cutting force and also temperature. This generation of high cutting force and temperature is due to the friction between the cutting tool and also the workpiece. Next is, what is titanium alloy? Titanium alloy is a metal commonly used in aerospace due to its durability characteristic. This durability characteristic of titanium alloy have made it become an extremely hard to machine materials. This is the example of the milling machine. This identify as conventional type. Next, we will go to the problem statement. During the milling machining, there is many heat generated due to the plastic deformation of wood material, friction at the tool chip interface, and friction between the clearance face of the tool and workpiece. Based on this figure, we can see that there is contact between the cutting tool and also the workpiece. Next is the usage of conventional cutting fluid. There is three main issues need to be highlighted here. Firstly is biological problems. Biological problem is related to the operators that are going to handle the cutting fluid during machining. This cutting fluid is recognized as hazard for them due to its toxicity. There is many risks while handling the cutting fluid. As example, during the machining, the cutting fluid maybe will splash and touching the operator. This will cause injury for them. Next is environmental pollution. This environmental pollution is related to the life cycle of the cutting fluid. This cutting fluid have a life cycle, and when the life cycle is end, the cutting fluid need to dispose correctly. There is risk where is the cutting fluid may be disposed into the drain, into the open water. This will causing the environmental pollution. Next is manufacturing cost. There is the cost for disposal of the cutting fluid is also high, and besides that, the maintenance also quite high for the cutting fluid because the cutting fluid is going to degrade over time. So we need to purchase a new one cutting fluid and and continues. Next is, what is the objective of the research? First is to analyze the effect of dry machining and solid lubricant on the surface toughness and surface integrity of titanium alloy after the milling process. Second is to compare the machining performance under dry machining and solid lubricant. Next is the scope of the research. First is milling machine. The cutting tool going to be used is titanium aluminum nitride. The machining environment is, first is dry machining, and second is machining with solid lubrication. The solid lubricant that going to be used is molybdenum disulfide and vegetable oils as base oil. The workpiece, the size of the workpiece is 0.1 m times 0.1 meter and 0.01 meter. Here is the literature review for the research. Here is the sum of the previous research that have been done during the machining of titanium alloy. First is the comparative investigation on using cryogenic machining in CNC milling of titanium alloy. The cutting tool used is solid carbide and the cooling agent is liquid nitrogen. The type of the cooling method is this cryogenic, and the parameters taken is spindle feed, feed rate, and depth of cut. And the result is the cryogenic cooling increase machinability, reduce surface roughness by 30 and 40%, increase to life, reduce power consumption, and specific machining energy. Next is the investigation of the effect of cryogenic machining. This one is the still cryogenic method used for machining of titanium alloy, and the result is increase surface roughness up to 30 and 40%. Next is using nanofluid and cryogenic. Then this research is comparing between the nanofluid and cryogenic, and the result is by using nanofluid, the average surface roughness is reduced to 8.72%, and the cutting force is reduced to 11.8%, and increased to life by 23% comparison with the cryogenic cooling. Next is minimum quantity lubrication using vegetable oil with nanoplatelet solid lubricant in milling titanium alloy. The method is MQL using vegetable oil and also the solid lubricant graphene nanoplatelet. And the result is reduction of the maximum flame wear width and steady state flame wear with nanoplatelet MQL, and most effective at reducing tool wear. Next is the effect of application of cutting fluid with solid lubricant in suspension during cutting of titanium alloy. The cooling agent solid lubricant used is graphite, and the base oil is integral oil. The result is reducing the tool wear, prolonging the tool life, and improving the surface roughness. Next is still using solid lubricant, and the solid lubricant used is graphite and PTFE, and the base oil is vegetable oil and also demineralized water. And the result is the use of the solid lubricant assisted MQC, resulting in the best result, reaching percentage reduction equal to 44%, 36%, and 29% compared to the dry, MQL, and wet strategies respectively. Next is the replacement of hazard lubricant by green coolant in machining of titanium alloy. The cooling agent is liquid nitrogen. The workpiece is titanium alloy. The method is still using cryogenic cooling, and the result is reduced up to 73% in force, but in MQL, it reduced up to only 5 to 28%. And the last is the effect of cryogenic cooling and minimum quantity lubrication of end milling of titanium alloy. The cooling agent used is HBN, hexagonal boron nitride. The base oil is ester-based vegetable oil, and the result is improved to life by up to 32% compared to the conventional fluid cooling condition in the deep axial depth of cut machining of titanium alloy. For the research gap, we can say that titanium alloy is a hard to machine material. Several cooling methods such as cryogenic cooling, nanofluid lubrication, and QL assisted machining with solid lubricant, and also by using cutting fluid can be when machining titanium alloy. The machining of titanium alloy by using mixture of molybdenum disulfide and vegetable oil has not been used, used based on the previous literature review. Next, we will go to the methodology. This is the flowchart of the experiment. We will go to start with the primary material. The material for the primary is the molybdenum disulfide with concentration of 1%, and in its particle size is between 20 to 80 micrometer. And the base form is vegetable oil. And then there will be mixing process between these two material using the sonication process. Sonication process is where the sound energy is applied to agitate the particle in the sample. The sonication process will be held at 40 kHz frequency for 40 minutes. And then when the particle is dispersed well, and we'll go to the next process. If the particle is not dispersed well, we'll go back to the mixing process and do it again. Next is we'll go to the milling machining process. This is the example of the machine that going to be used, and the machining parameter is here. With the workpiece used is titanium alloy, and cutting tool used is titanium alloy nitrate coated carbide, and the feed rate is constant 0.1 mm per tooth, and the cutting speed also constant 115 meter per minute, and the depth of cut is 5 millimeter, and is constant for both experiment. And the machining condition is under dry machining and also solid lubricant with vegetable oil. Next, when the machining is done, we will go to the surface roughness test using SJ310 device. This device is going to be used to obtain the surface roughness value, and the value will be taken 5 times, and the average will be taken. And next is SEM, scanning electron microscopy. SEM will be used to scan the surface of machine materials by using focus beam of electron. Then the image will be recorded and compared to analyze micro defect on it. For the conclusion, as expected result is the molybdenum disulfide particle is successfully dispersed in vegetable oil for during end of the project, and the outcome is low surface roughness value of titanium alloy can be obtained by using the solid lubricant as the cooling method, and better surface morphology can be obtained by when using the solid lubricant compared to the dry machining. That's all from me. Thank you.